Good morning to all of you. Myself, Professor N.V. Adpe from SND College of Engineering and Research Center, Evla, working as a assistant professor in Electrical Engineering Department. So, today we will discuss the new topic of course, numerical methods and computer programming. In previous videos or previous lectures, we already studied that the basic concept of numerical computation, normalized floating point form, and algebra of floating point form, errors, types of error, and numericals on errors to find the errors in the equation. Now, in that lecture, we study we will study the concept of root of equation. Suppose any equation is given, that is one polynomial equation is given, and to find the root of that equation by using number of techniques, it is called as root of equation. Then what is the root of equation? The one of the most common problem encountered in energy analysis is that given a function, find the value of x for which f of x is equal to 0, the solution value of x are known as the root of equation f of x is equal to 0 or zeros of the function f of x. Means, suppose we have one polynomial equation having function f of x, having function f of x, and the value of x, it at which the function satisfy the condition, that is f of x is equal to 0, and this is nothing but the value of x. The value of x is nothing but the root of equation. It may be the real root or complex root. In general, an equation may have any number of real roots or real roots is the x coordinate of the point at which y is equal to f of x towards the x-axis. Suppose in that figure, first figure, this is a curve. This is a curve having a polynomial equation, one polynomial equation, and the value of and the root of that equation is the curve. Any curve or any graph curves the x coordinate. The root of equation is the x coordinate at which the curve intersects x axis. Means x axis ला ज्यावेळेस हा कर्व इंटरसेक्ट करल आणि जो पॉइंट असेल कुठला x ऍक्सिसचा, त्याला काय म्हणतो आपण, दिस इज अ रूट ऑफ इक्वेशन. इन सेकंड फिगर, similar, the C, this is a curve and this curve intersects x-axis at point C. Then the C is the root of equation. C is root of that equation. For example, sin x minus 0 is equal to 0 has a single root, that is x is equal to 0. X is equal to 0. Whereas tan x minus x has finite number of roots, that is large number of roots, that is x is equal to 0 plus minus 4.493, means that there are number of complex roots. The figure below shows graphical representation of root. This is your graphical representation of concept of root. The NA curve intersect x-axis at one point, then this is your root of equation. Then next, how there are two methods to find the root of equation. First one is direct method, second one is indirect or iterative method. In first direct method, we can find the root of equation by using direct method, that is numerical method. The direct method gives the exact value of the roots in a finite number of steps. In the direct method, the number of steps required to find the root, find the answer, exact value, it is the time required or the number of steps are less. Also, we assume here there is no round of errors. There is no round of errors. And the direct method determines all the roots of the equation at the same time. At the same time means, suppose the center split or synthetic division or any other uh, method, then by using that the number of roots of any equation find at a time, it will be find at a time. But in second method, that is iterative or indirect method, these methods are based on successive approximation. I mean, this method suitable, having operates on successive approximation, means having they have given approximate root, first approximate root, and from this approximate root we can find the exact root, by using convergence method. The general procedure is to start with one or more initial approximation. Means in that iterative or indirect method, one or two initial approximations are given to the root and obtain a sequence of iterations which in the limit converges to the actual or true solution of the root. Means in that after the initial guesses or initial approximation, then we can obtain the sequence of operations or make the number of iterations, and by in the limit of the convergence, and find the solution which is near to the or which is actual or true solution of the root. This is your direct method and indirect method. The number of methods in that, the direct method in that, the Descartes rule of sign. In that, to determine the nature of sum of the roots of an equation, it is not necessary to solve it always. Means for finding the nature of root, means suppose in that what is the nature of root, means it is positive root or negative root or complex root. This will be directly find by only the observation. This is from the Descartes rule of sign. For example, if equation contains only even powers of x and all are of same sign, then equation has no real roots. Equation has no real roots. Means suppose any one equation, suppose in that equation 2x raised to 4 plus x square plus 10 is equal to 4. In that only the power of x is only even power, that is 2 and 4, and the number of signs does not changes, then it is having no real roots. These and many other observations can be obtained using theorem known as Descartes rule of sign. This will be found by using the rule, that is by using theorem, that is Descartes rule of sign. What is Descartes rule of sign? An equation f of x is equal to 0 cannot have more positive roots than there are changes of sign in f of x, and cannot have more negative roots than there are changes of sign in f of minus x. Means in that theorem we find the number of positive roots, number of negative roots, maximum number of positive roots and maximum number of negative roots by only the observations. That is to find the number of positive, maximum number of positive roots, check the number of sign changes, check the number of sign changes in f of x, and to find the maximum number of negative roots, to check the number of sign changes in a f of minus. If size of the terms in a polynomial are plus plus minus minus plus minus minus plus minus minus, in that the number of sign changes is from plus to minus first, again minus to plus second, plus to minus third, minus to plus fourth, and if four plus to minus, it is 5. 5 times the sign will be changes, means in that equation the maximum number of positive roots are 5. There are maximum 5 positive roots. For example, so to take the or to find the number of positive and negative roots in that equation, x raised to 9 plus 10 x raised to 8 minus 3x cube plus 8x plus 5 is equal to 0. In that plus plus, in that plus to minus 1 and minus to plus 2, means in that there are 2 times sign changes in a equation, that is f of x, means there are at most the maximum number of positive roots are 2. In that equation the maximum number of positive roots are 2. Then now f of minus x, calculate the f of minus x. X is replaced by minus x. Then after the calculation, the equation is minus x raised to 9 plus 10x raised to 8 plus 3x cubed minus 8x plus 5. Then minus to plus, again plus to minus and minus to plus. Means there are 3 times, the sign changes in the f of minus x. Therefore, the maximum number of negative roots in that equation is 3. Means in that equation the number of positive roots, maximum number of positive roots are 2 and number of negative roots are 3. Okay, this is our Descartes rule of sign. So means in that lecture we studied that the concept of root of equation how to find the root of equation by using number of methods, that is direct method and indirect method, and Descartes rule of sign. Descartes rule of sign. Next one is intermediate value theorem. Intermediate value theorem. If f of x is a continuous function on a b, then for every d, then every d between f of a and f of b, there exists a value c in between a and b such that f into c is equal to d, is equal to d. Means in that if a function f of x is a continuous function in a and b, then there is a one root exists when f of c is equal to d. This theorem can be extended to find whether an equation f of x is equal to 0 has a root in interval a comma b. Using the same concept in the theorem, we can say that f of x is a continuous function on AB such that f of a and f of b have opposite signs. Then there exists a root of equation f of x is equal to 0 in interval a comma b. Means suppose f of x is a continuous function in a interval that is a and b, then f of a and f of b having opposite sign, means f of a into f of b, it is negative, that is less than 0, then there exists a root. There exists a root of equation f of x is equal to 0 in the interval a and b. How to find it? Find the interval a b such that f of a into f of b is less than 0. Apply intermediate value theorem. F of x is equal to 0 has at least one root in a comma b. So stop here. In next lecture, we will discuss the next topic, that is Barjavita method. So stop here and see you in next lecture.